Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections. Today, we are tracking a pathogen that masquerades as a common childhood nuisance, but harbors a much darker, potentially paralyzing secret. You might know it as a daycare bug, but you're about to meet the sinister viral family behind hand, foot, and mouth disease.
Yeah, it really is an infection that hides in plain sight. I mean, it thrives in the exact places we usually consider the safest.
Exactly. So I want you to just picture a bright Tuesday morning at your local daycare center. Toddlers are sharing plastic blocks, fingers are covered in paint, hands are unwashed, and, snacks are being passed around. A child develops a slight fever and suddenly refuses to eat. It seems completely routine. You probably wouldn't even give it a second thought.
But if we actually look at the clinical reality, brushing this off is a huge mistake. Because in a single year, a massive surveillance effort in China recorded millions of these infections, literally millions. And buried in those numbers was a terrifying mortality rate of 0.03%, which was primarily driven by severe, sudden onset neurological complications.
Which is just staggering. I mean, a daycare bug causing brain damage. And the presentation can shift overnight. Like in 2021, France was hit by this rapid explosive surge of over 300 to 400 cases featuring atypical, highly aggressive symptoms that just caught public health officials completely off guard.
Right, because the viral landscape for this pathogen is evolving rapidly. We are literally watching it adapt in real time.
So how does a common rash spreading through a kindergarten classroom travel to the brain and mimic polio? In this deep dive, we really need to understand the biology of this threat. What exactly is hand, foot, and mouth disease, or HFMD?
Well, so HFMD is what we call a viral exanthem, which is basically the medical term for a widespread rash that comes with systemic symptoms. The pathogens responsible belong to the Picornaviridae family. And specifically, we are dealing with enteroviruses.
Okay, enteroviruses.
Yeah, they are single-stranded RNA viruses. But a really critical detail here is that they are non-enveloped.
Wait, non-enveloped? That sounds like it lacks armor or something. Shouldn't that make the virus fragile?
You would think so, right? But it is actually the exact opposite,
Right.
which is a super common misconception. I mean, many viruses like influenza or SARS-CoV-2, they have this outer lipid envelope, a layer of fat.
And fat is easily dissolved by soap and alcohol hand sanitizer.
Exactly. That destroys those viruses.
Yeah.
But because enteroviruses lack that fatty envelope, their outermost layer is this rigid, densely packed protein shell. It acts like a microscopic suit of armor, which makes them incredibly resistant to alcohol, to drying out, and just many common environmental stressors.
So they're built like little tanks. And just to be clear, there isn't just one type of this virus circulating, right? It's not a single entity.
No, not at all. Think of it more like a massive family tree with several problematic branches. You have Coxsackievirus A16, which is the annoying cousin you sort of expect to see. That one causes the classic milder illness we mostly see in the United States.
Right.
But then you have enterovirus 71, or EVA71, and that is the black sheep of the family. EVA71 has a specific affinity for the nervous system. That's the variant responsible for the severe brain swelling and the massive deadly outbreaks in East and Southeast Asia.
And now there's a new branch of the family taking over, from what I understand.
Yeah, Coxsackievirus A6, it has rapidly become globally dominant, and it is the one responsible for the atypical, unusually severe, and highly widespread rashes that are just sweeping through communities today.
Before we track where these variants are moving, I want to clear up a major point of public confusion. Because when people hear foot and mouth, they almost always immediately picture agricultural outbreaks on farms.
Right, yeah. They share a similar name just due to the visible symptoms they cause. But they are entirely different biological entities. I mean, foot and mouth disease or hoof and mouth disease, that affects cattle, sheep, goats, and pigs. It belongs to a different viral genus entirely.
So humans and cows might share a pasture, but they absolutely do not share this virus.
Exactly. Humans cannot contract the animal disease, and animals do not catch or spread the human HFMD viruses.
Well, with that cleared up, how is this armored virus actually moving across the globe? We mentioned those millions of cases in China earlier, and the data shows over 90% of those infections hit children under the age of 5, with a massive spike in cases occurring specifically in late spring and early summer.
Yeah, and that seasonality is a massive clue to how the virus survives. There was this fascinating environmental study conducted in the Mekong Delta in Vietnam. They found a direct, positive correlation between rising environmental temperatures, higher humidity, and steep spikes in HFMD incidence.
Why does the weather dictate a viral outbreak, though?
It comes back to that rigid protein shell we talked about. It's highly stable in warm, humid environments. So when the weather gets hot and sticky, The virus survives much longer on surfaces and in water.
Wow.
Now, it basically expands the window of time the virus has to find a new host before it degrades.
Which means as global temperatures rise, the map of where and when this virus strikes is just going to expand. If the environment is becoming more hospitable to it, how is it physically moving from child to child so efficiently?
It utilizes these highly effective overlapping transmission routes. The primary path is fecal-oral.
Which is rampant in daycares during diaper changes or, potty training.
Oh, absolutely.
Yeah.
But it also spreads through respiratory droplets when an infected person coughs, sneezes, or even just talks. And finally, it spreads through direct contact with the infectious fluid inside the blisters it creates on the skin.
I always picture the spread of this virus like glitter in a kindergarten classroom. Once a kid gets glitter on their hands, they touch a shared block, then the next kid grabs the block, rubs their eye, or puts their fingers in their mouth. It's just this invisible, seamless chain reaction.
That is a perfect analogy. And unlike glitter, you can't just wipe this off with a quick squirt of hand sanitizer. The timeline of contagion makes that chain reaction incredibly difficult to break.
How so?
Well, the incubation period, which is that silent window between exposure and the first symptom, is usually 3 to 6 days.
Okay, so how long is that child acting as a spreader once they are actually infected?
A patient is most highly contagious during the first week of illness. But the virus doesn't simply vanish when the fecal breaks. It continues to shed in the throat for up to 4 weeks.
4 weeks?
Yes. And it sheds in the stool for an astonishing 6 weeks after the initial infection.
Wait, 6 weeks? Are you saying a child could be completely recovered back at school and still shedding the virus in their stool a month and a half later? How is that even biologically possible?
Because the virus actively replicates in the lymphoid tissue of the lower intestine. It essentially sets up a microscopic manufacturing plant in the gut.
Ah, I see.
And that plant continues to churn out viral particles long after the systemic immune response has cleared the virus from the blood. This prolonged shedding is exactly why poorly chlorinated recreational water is such a hotspot.
Like public pools.
Exactly. If a public pool isn't aggressively treated and a shedding child contaminates the water, that protein-armored virus survives. Other swimmers can catch it simply by accidentally swallowing a mouthful of pool water.
That is terrifying. Because it exploits shared environments so efficiently, the demographics in the crosshairs are highly specific, right? Children under 5, sometimes up to age 7, are the primary targets because of immune naivety. Their immune systems simply have no blueprints for these enteroviruses.
Right.
But I have to ask, is this strictly a pediatric problem? I know adults who have contracted it and their symptoms were brutal.
Adults absolutely contract it. If an adult encounters a high viral load or a newly emerging strain like Coxsackievirus A16 that their body has never seen, their immune system will struggle.
Makes sense.
But we also really have to look closely at highly vulnerable populations. Immunocompromised individuals face the risk of systemic, prolonged viral replication.
What about pregnant women? If an adult gets infected, does it actually affect the fetus?
It is a critical concern, yes. During the acute phase of the infection, when the virus is actively multiplying in the mother's bloodstream, it can cross the placental barrier.
Oh, wow.
Yeah. While rare, clinical studies do show an association between certain Coxsackievirus infections and spontaneous abortions or severe neonatal infections, because the virus induces intense placental inflammation and can actually attack fetal tissue.
So once this pathogen bypasses a vulnerable host's immune defenses, what is it actually doing to the body? Let's walk through the timeline of the symptoms. What does the infection feel like?
The initial invasion is marked by 3 to 5 days of a low-grade fever, general malaise, and frequently a sudden refusal to eat or drink.
And that refusal to eat is usually the first red flag for a parent. I'm assuming that happens because of the ananthem, the mouth sores.
Yes, exactly. The virus targets the mucosal lining of the mouth. It creates these painful red spots on the tongue and the inside of the cheeks.
Ouch.
And these spots rapidly blister and rupture, leaving superficial ulcers with a gray-yellow base surrounded by a fiery red rim. Every swallow becomes excruciating.
And shortly after that, the exanthem appears, right? The outward skin rash. We're talking about 2 to 6 millimeter flat or raised red spots on the palms of the hands, the soles of the feet, and sometimes creeping up the legs and buttocks. But this rash doesn't behave like chickenpox.
No, it doesn't. The lesions are typically non-pruritic, which just means they do not itch. And because the virus usually restricts its cellular destruction to the superficial layers of the epidermis, the lesions generally heal after about 10 days without leaving any permanent scars.
Okay, but that is only the standard presentation. How does a superficial skin rash suddenly lead to the neurological horrors we discussed earlier? I mean, how does HFMD mimic polio?
This happens when the EVA71 variant is involved. EVA71 has specialized receptor binding sites that allow it to literally slip past the blood-brain barrier.
And once it's in the brain?
Once inside the central nervous system, it actively attacks and destroys the gray matter. It can cause aseptic meningitis, which inflames the brain's lining, or acute cerebellar ataxia, which destroys a child's muscle coordination.
And what about the paralysis?
Right, the virus directly targets and kills the motor neurons in the anterior horn of the spinal cord and the brainstem. These are the physical cellular wires that tell muscles to move.
So when those die?
When those neurons die, the muscles they innervate instantly go limp. This is acute flaccid paralysis.
The permanent destruction of the nervous system from a daycare virus. It's just chilling. And even if a child avoids the neurological complications, there is a bizarre delayed symptom that happens weeks after the rash is cleared. I was looking through the case files for this deep dive and saw reports of children's fingernails and toenails simply falling off.
Yeah, it's called onychomatosis. During the acute phase of the infection, the sheer stress of the systemic inflammation, combined with the virus replicating, temporarily halts cellular division in the nail matrix.
The matrix is the tissue under the cuticle that manufactures the nail, right?
Exactly.
So the factory just shuts down.
Completely shuts down. For a few days, no new nail is produced. Weeks later, as the nail grows out, that invisible gap of missing tissue reaches the nail bed.
And the nail just pops off.
The structural integrity is broken, and the entire nail simply detaches from the finger. I mean, it does grow back, but it is deeply alarming to witness.
Deeply alarming is an understatement. With the potential for excruciating ulcers, nail loss, and acute paralysis, how do clinicians fight back? What is the medical protocol once someone is infected?
The really frustrating reality of modern medicine is that we have zero licensed antivirals for HFMD in the United States. We have no pharmaceutical weapon to kill the virus once it has established an infection.
So we rely entirely on supportive care.
Just managing the fallout, yeah.
And because of the severe pain from the mouth ulcers, dehydration has to be the immediate crisis. A child will literally refuse water because swallowing feels like broken glass.
Right. Dehydration is actually the primary cause of hospitalization in HFMD cases.
Yeah.
Pain control is basically the only way to facilitate hydration.
There is a specific clinical trick doctors use for this, right? The magic mouthwash.
Yeah, it is a mixture of liquid ibuprofen and diphenhydramine, commonly known as Benadryl. For older children who can safely gargle and spit, this mixture coats the superficial ulcers.
And that helps.
It really does. The ibuprofen reduces the intense local inflammation, and the diphenhydramine acts as a mild topical anesthetic. It numbs the pain just enough to allow the child to take a few sips of water.
But wait, if local inflammation is causing so much damage, why wouldn't a doctor just prescribe a systemic steroid to calm the whole immune system down?
That is a dangerous trap. And it's something parents must be aware of. Steroids work by broadly suppressing the immune system's response.
Right.
So if you mute the body's alarm system and suppress the immune cells fighting the infection, you essentially give the virus free rein to replicate exponentially.
Which makes it worse.
Much worse. That massive spike in viral load significantly increases the chances of the virus breaching the blood-brain barrier and causing severe neurological damage. Steroids actually increase the risk of severe HFMD.
So we have no antivirals, and we absolutely cannot use steroids. The obvious answer is a vaccine. Why don't we have a childhood shot for this to prevent the infection entirely?
Well, there actually is a highly effective vaccine, but it highlights a massive geographic divide in public health. It is not available in the United States or Europe.
Wait, where is it, and what makes it work?
In China. Driven by the massive EVA71 epidemics they faced, researchers there developed an inactivated whole virus aluminum adjuvant vaccine.
That's a mouthful.
It is. But they tested it on over 10,000 participants, and it demonstrated a 94.7% efficacy rate against severe disease, lasting roughly 2 years.
Okay, let's break down the mechanics of that. Inactivated whole virus aluminum adjuvant. What does that actually mean inside the body?
So inactivated whole virus means they took the actual EVA71 virus and chemically killed it.
Okay.
The physical protein shell remains perfectly intact, but its internal genetic machinery is dead, so it cannot replicate or cause illness.
But the immune system often ignores dead debris, right?
Exactly. And that is where the aluminum adjuvant comes in. The adjuvant is basically a chemical irritant mixed in with the dead virus. It triggers a massive local alarm in the immune system.
Forcing a response.
Right. forcing white blood cells to rush to the area, discover the dead viral shells, and manufacture specialized antibodies against them.
If it works so well, why isn't it part of the standard global childhood vaccine schedule? I mean, why can't I get this for my kids?
Because it is a highly specialized sniper rifle. It specifically targets the structural proteins of the ED71C4A strain. It does absolutely nothing against the Coxsackievirus A16 strain common in the U.S., and it provides zero cross-protection against the globally dominant Coxsackievirus A6. Other researchers are working on broad-spectrum, virus-like particle vaccines and DNA vaccines, but they remain bogged down in clinical trials.
Which leaves us with the oldest tools in the public health playbook. We have to prevent the virus from physically entering the body in the first place.
It all comes back to mechanical hand washing. We discussed the virus's rigid protein shell earlier. Alcohol-based hand sanitizers simply cannot crack that armor.
So the squirt a sanitizer at the daycare door isn't enough.
Not at all. To remove the virus from your skin, you must scrub with soap and water for at least 20 seconds.
Because the soap physically traps the viral particles in these chemical cages called micelles, and the friction of scrubbing just washes them down the drain. You are essentially evicting the virus, not killing it.
Exactly. And environmental control is equally vital. High-touch surfaces and shared toys in communal spaces must be aggressively disinfected with bleach-based solutions that can actually denature those viral proteins.
Now, if an outbreak hits a daycare, the first question every parent asks is, when can my kid go back? We know they shed the virus in their stool for 6 weeks. We obviously can't quarantine a toddler for 2 months. So what is the actual line in the sand?
Public health protocols dictate strict criteria for returning to a communal setting. The child must be fever-free for at least 24 hours without the use of medication.
Okay.
They must feel well enough to participate in normal activities. And crucially, they must have absolutely no uncontrolled drooling.
Because the saliva is packed with the virus from the mouth ulcers. Drooling is essentially an active, uncontrolled leak of infectious fluid.
Right. If they are drooling, they are actively spreading the infection to literally every surface they touch.
Looking at the data today, how are these basic hygiene protocols holding up against a virus that is actively mutating?
Well, HFMD remains an aggressive endemic threat globally. The current surveillance shows Coxsackievirus A6 thoroughly dominating the landscape in the United States and Europe right now.
And that's the one causing the atypical symptoms.
Yes, it is causing wider rashes that spread to the arms and trunk, higher fevers, and significantly more severe cases in adults than we've historically seen.
And knowing what we do about how this virus thrives in heat and humidity as global temperatures continue to rise, the transmission windows are going to widen. The geographical map of outbreaks is only going to grow. So what is science doing to prepare for the next major EVA71 wave?
The pharmacological pipeline is active, thankfully. Researchers are testing an anti-peak cornaviral agent called pleconaral, but they are also looking at more advanced therapeutics like translation inhibitors and molecular decoys.
Wait, how do those work? How do you stop a virus without just poisoning the surrounding human cells?
Think of the virus like a hacker slipping into your cell and handing a malicious blueprint to your cellular 3D printers, forcing them to print millions of new viruses.
Great analogy.
A translation inhibitor chemically jams the 3D printer so it physically cannot read the hacker's code. The replication just stops.
And the molecular decoys?
A molecular decoy works outside the cell. The drug floods the bloodstream with fake cellular doorways, so the virus binds to the decoy instead of our actual cells.
Neutralizing the threat before it ever breaches the cellular wall.
Exactly. The ultimate goal is to build a chemical barrier that protects the central nervous system.
We are mapping fake doorways and jamming cellular printers to fight a virus that thrives on shared plastic blocks. It forces a deeply unsettling shift in perspective. As a society, we spend our time scanning the horizon for the next great pandemic, and exotic pathogens spilling over from a distant jungle, but we entirely overlook the vast, silent evolution of viruses already circulating right now in our elementary schools and our homes. Hand washing isn't just a polite ritual to avoid a pesky rash. It is literally the only physical wall standing between our communities and a virus capable of paralyzing our children. Stay informed, stay prepared. This has been Outbreak Brief.